So for this problem, we're given a recursive formula. Since notice that we're given the first term and then we're given the pattern. So remember, we call these recursive formulas. And all of these are very similar. We start with that first term in our sequence, which is 13. And then we're given this pattern where we're told the nth term of our sequence D is equal to the n minus 1 term of the sequence D plus 17. Or another way to phrase this, because this can be a little bit confusing at first, is that the nth term is found by taking the term before that and then adding 17 to it. So for instance, if we want to find D of 2, so this is when n is equal to 2, our second term, we're going to plug 2 in here. So it's D of 2 minus 1 plus 17. Well, 2 minus 1 is just 1. So this is D of 1 plus 17. But we know what the first term is in this sequence D. It's 13. So we're taking 13, and then we're going to add 17 to that, and we get 30. And next, we can figure out D of 3. So again, for this one, we're looking for the third term, or when n is equal to 3 in our formula. So we plug in 3 there. So we have D of 3 minus 1 plus 17 to find that next term in our sequence. And 3 minus 1 is 2. So this simplifies to D of 2, which, again, this is just the second term in our sequence, plus 17. And we know the second term, well, that was 30. We found that in the previous formula. So we have 30 plus 17, which is 47. So 47, that's our third term in the sequence. And to find the fourth term, well, we plug in n equals 4 here. And so we have D of 4 minus 1 plus 17. And D of 4 minus 1 is really just D of 3 plus 17. And D of 3 is just our third term. We found that. That's 47 here. And so this would simplify to 47 plus 17. So that brings us to 57 plus 7, which is 64. And we just wanted to go to the fourth term. So 64 would be our final answer here. But just to summarize, since this pattern here that we're given in these formulas, it looks confusing at first. But all it's saying is that to find the next term, we're going to take the previous term and add 17 to it. So just to complete the pattern, notice that from one term to the next, we're just adding 17. So you don't need to do all this work for this every time, but it's helpful to do it a couple times just to see for yourself how the pattern works. So we don't need to write D of 5 and plug it all in here. What we could do is just add 17 to this. And if we add 7, that brings us to 71. And 10 more brings us to 81. And we could keep going from there. Just add 17 again, and that brings us to 98. And this, of course, goes on forever. So in general, with these recursive formulas, it's always to find the nth term. You take the term before that, and then you add what we call the common difference. And for this problem, our common difference for this arithmetic sequence was 17. So let's take a look at an explicit formula. Just to get the hang of using both of these types of formulas. So this one, we want to find the 16th term in the sequence. And like I mentioned, these are called explicit formulas. And you'll recognize these explicit formulas when they're asking for a specific term in the sequence, and they just give you a formula for it. And they don't directly tell you what the first term is, but in these formulas, it's always, for our sequence, A of n, it's the first term, so -6 in this case, plus D, which is our common difference, multiplied by n minus 1. So D here will be multiplied by n minus 1. Since in any arithmetic sequence, you take the first term and then you add that common difference a whole bunch of times. And we don't add the common difference for the first term. Since notice if you find A of 1, this just simplifies to 0 here. and you just get that first term. And for a of 2, we take our first term, and we're just adding d to that. Since notice, 2 minus 1 is 1, so you get plus d, plus that common difference. So the third term, you add the common difference twice. The fourth term, you add the common difference 3 times. So it has to be d times n minus 1. You're going to add that common difference one less time than the number of terms you're looking at. So we want to find the 16th term, and frankly, you can just plug 16 into the formula anywhere you see n. But it is good to be able to understand this and where the formula comes from, since eventually you're going to want to create these formulas for yourself. So in our case, we're plugging in n equals 16 because we want to find the 16th term. So a of 16 is minus 6 plus 3 times 16 minus 1. So minus 6, that's our starting term. And then our common difference, in this case, is 3. And so we're going to add 3 one less time than the number of terms there are. Or in this case, we're going to add 3 15 times. So we have minus 6 plus 45. And if you take away 6 from 45, that brings you to 39. So it looks like 39 is the 16th term in the sequence. And you could, of course, generate the whole sequence for yourself, since you can just start with a of 1. We know that's minus 6. A of 2 is minus 6 plus 3, since 2 minus 1 is 1, which, of course, is just minus 3. A of 3, you can calculate, would be 0. And you can see the pattern, that it starts at minus 6, then goes to minus 3, then 0. But you're just adding 3 every time. So 3, 6, 9, and so on. And you can figure out for when n is 16 that you get up to 39. And this can be a little bit tedious, but at the same time, you can directly check these.